Hello? Hello? Right. Two, three. Right. Okay. Yeah, so most of them are there. Right. Okay. Yes. Okay. We'll start the class. Okay. Okay. So in the previous class, we had stopped in seeing uh, we had just started with uh, the working of a four-stroke petrol engine. So we'll continue with that today. Okay. So yes, so let us start from the first stroke, which is generally called as the suction stroke. Okay, which is called as the suction stroke. Okay, so we can see this video onto the screen over here. So as of now, the piston is at the TDC, right? It is at the TDC, and now let us see this. So in the first stroke, it is called as the suction stroke. Okay, the piston moves from TDC to BDC, right? So during this time, what happens is that the piston moves towards the BDC, and the volume in the piston cylinder arrangement increases. And during the same time, what happens is that when the piston is moving from TDC to BDC, during that time the inlet valve is open, right? And thereby what happens? The air fuel mixture enters through the inlet valve, which we can see here as the green color region, because it is going to be added in the form of fine atomized sprays. So just look at this. So once the piston reaches the BDC, the inlet valve is going to be closed. So now what happens actually in the suction stroke is that when the piston moves from TDC to BDC, inlet valve is going to be open, and since the piston is going to move towards the BDC, the crankshaft is going to rotate for half a rotation. It is going to rotate for half a rotation. Yes, and once it reaches the BDC, right, the inlet valve is going to be closed. The inlet valve is going to be closed. Okay, and now the piston moves from BDC to TDC, compressing this air fuel mixture that is present inside the piston cylinder arrangement. Now we can see that Now once the piston is going to move from BDC to TDC, the air fuel mixture is going to be compressed. You don't have so much of volume or space as it was during the suction stroke. So this is going to be compressed. That is the air fuel mixture. So thereby what happens for this air fuel mixture over here during the compression stroke, the pressure of this is going to increase as the space is being reduced. But during the the compression stroke, the inlet valve and outlet valve both are closed. The second one is that once the piston starts to move from BDC to TDC, the crankshaft is going to rotate for another half a rotation. So both the valves are closed, which has been indicated over here. Yes. So once it reaches the TDC, okay, there is only a small volume that is left behind. That is the clearance volume, in which in that particular space only all this air fuel mixture is going to be compressed. Now at the end of the compression stroke, we have to note this. We can see here clearly onto the screen over here that since it is a petrol engine, there will be a spark plug, okay, through which a spark will be generated. This spark will be generated when at the end of the compression stroke, right? That is when the piston has compressed the air fuel mixture, and it is this air fuel mixture is at a higher pressure and resting at the clearance volume space. So during this time a spark is being introduced. So now what happens in the air fuel mixture, it is already at higher pressure, okay, and a spark is being introduced. The fuel, it has the combustionable properties, so combustion is going to take place at the end of the compression stroke. That is what is being indicated over here. So combustion is going to happen at the end of the compression stroke. Now because of this combustion, okay, because of this combustion, a force is being exerted in all directions. So the only movable part over here is only the piston. So there is nothing that can be done. So because of this combustion, the force that is being exerted is going to be onto the piston head or onto the piston, right? So thereby the piston starts to move towards the BDC from TDC once again, right? Right. So now we can see that the piston is going to move from TDC to BDC. So yes, now during the power stroke, because of the combustion, the piston is going to move towards the BDC. Now again, during this time also, if you see here, both the valves, that is the inlet valve and exhaust valve, both are closed during the power stroke also. Now the piston is going to move towards the BDC. So since the piston is going to move, the crankshaft is going to rotate for another half a rotation. Yes. Now at the end of the power stroke, that is when the piston has reached BDC after combustion, right? The inlet valve will be closed, the outlet valve will be open at the end of power stroke, so that all this exhaust gases has to go out through this exhaust valve through, and then it is being let out to the atmosphere through the silencer, right? So for this is the next stroke, which is called as the exhaust stroke. Now we can clearly see that once the piston has reached BDC, the Once the piston has reached the BDC, the outlet valve is open. The piston starts to move from BDC to TDC, pushing all this combustible gases, the exhaust gases that is present over here, to be forced out, right? So that is what happens in the exhaust stroke. So only the exhaust valve is open, inlet valve is closed, and the piston pushes towards the TDC, thereby pushing all these gases through the outlet valve. So once this piston has reached the TDC, right, the exhaust valve is going to be closed, okay, and thereby one complete cycle has been over, right? So thereby what happens? One complete cycle, that is 4 strokes, has been completed and the cycle repeats. So once again, the piston is now actually at the end of exhaust stroke, it is at the TDC. Now after these 4 strokes, once again the cycle is going to start from the suction stroke, right? That is, it is going to draw the air fuel mixture, piston is going to move from TDC to BDC, inlet valve is going to be open, right? Yes. Now you can see all these 4 strokes happening. So this action takes place so fast that we generally have seen some during whenever we see any specifications of a vehicle, the piston has got some 3000 rpm, 5000 rpm and all, right? That means the crankshaft is going to rotate for 300 rpm, right? That is 300 times per minute, 300 rotations per minute, or 500 rotations per minute, right? Nowadays we get this reading onto the dashboard also, right? What is the speed of the engine, right? Okay, now here they have shown the complete cycle. So during the combustion stroke, now just look here, as the piston moves from TDC to BDC, the crankshaft is going to rotate by half a rotation. And once again, when the piston is going to move from BDC to TDC, the crankshaft is going to go for another half a rotation, right? So this cycle continues, okay? And this is how the 4-stroke petrol engine works, right? So I'll just replay it once again so that you can visualize all the 4 strokes once again. Okay, so the first stroke, that is the suction stroke, piston moves from TDC to BDC, inlet valve is open, crankshaft goes for half a rotation, air fuel mixture enters into the piston cylinder arrangement. Now why this happens is that since the piston moves from TDC to BDC, okay, a low pressure region is being created into the piston cylinder arrangement. Thereby, this inlet valve is connected to the air fuel mixture flow point. So thereby what happens? Because of this low pressure, the air fuel mixture enters into the piston cylinder arrangement. So the compression stroke, which is the second stroke, in this time both the valves are closed, okay, and the piston moves from BDC to TDC, compressing the air fuel mixture that is present inside the piston cylinder arrangement. And at the end of the compression stroke, since it's a petrol engine, a spark will be introduced, okay, due to which the combustion is going to take place. So at the end of compression stroke, combustion is going to take place as spark is being introduced, and because of this combustion, the piston moves from TDC to BDC. So that is the third stroke. So now the piston moves from TDC to BDC after combustion, which is called as the power stroke. Now at the end of the power stroke, that is when the piston reaches the BDC, the outlet valve is going to be open, Okay, now this exhaust stroke, that is the fourth stroke, okay, happens from BDC to TDC, okay, and what happens, outlet valve is open, and thereby what happens, it is going to push out all these gases outside through the exhaust valve. So all this space is now cleared into the piston cylinder arrangement now. So all this burnt gases is being sent out, okay, and now the piston is once again at the TDC at the end of fourth stroke or at the end of the exhaust stroke. Now after these four strokes, the cycle repeats. So it undergoes once again for suction stroke, compression, power, and so on. So here we can see that all the engine to be working continuously, that is, it is undergoing all the four strokes. So during the power stroke, after combustion, the piston is going to move downwards and the crankshaft is going to rotate for half a rotation. So because of this mechanism and by the working nature like this, we are able to convert linear motion of the piston into rotatory motion on that we can receive or tap it from the crankshaft. Come back to this. Come back to this. And now we have seen how these four strokes work in an IC engine. Now let us see that we'll have to go along with the PV diagram, that is the pressure versus volume diagram for the four strokes, okay, that is happening in a petrol engine. So what is the change in pressure? What is the change in volume for every stroke and at every moment? That we also will have to write. Okay. So now let us look at only about the PV diagram. I'll explain this, how to write this PV diagram and understand this PV diagram. So now coming back to the first stroke. Okay, we know that now in the suction stroke, the piston moves from TDC to BDC. Volume into the piston cylinder arrangement, as we can see, it increases and the inlet valve is open, that is, it is connected to the atmosphere. Okay, so there is no change in the pressure. Okay, but the volume into the piston cylinder arrangement increases as the piston moves from TDC to BDC. Thereby, during the suction stroke, okay, the volume increases over here. We can see this blue arrow mark that is being represented from here to here, which indicates during the suction stroke, the volume increases at constant pressure. So at the end of the power stroke, sorry, at the end of the suction stroke, it is going to reach the point B. So that is the end of the suction stroke. Now the second stroke is the compression stroke, where inlet valve and exhaust valve both are closed, and the piston moves from BDC to TDC, compressing the air fuel mixture. That means the pressure inside this piston cylinder arrangement is going to be increased. Now as the piston moves from BDC to TDC, the volume decreases. At the same time, the pressure also increases. That we can see here, which has been drawn onto the PV diagram over here. So once at the end of the suction stroke, the compression stroke is going to start. So the compression stroke is going to start, that is, the piston moves from BDC to TDC, compressing it, volume decreases. So volume decreases, so we can see that from point B it is going to reach point C. So by so much the volume is going to be decreased because the piston is going to move from BDC to TDC, but at the same time, since the valve is closed, the pressure is also going to increase. So we can see that there is a change in the volume as well as change in the pressure also. Now at the end of the compression stroke, a spark has been introduced, okay, and combustion takes place. So this is going to happen within a very small fraction of second. So thereby it will almost, it is theoretically speaking, the compression stroke, sorry, the combustion is going to take place at constant pressure. There is not much movement of the piston, that is, there is no change in the volume, okay. So thereby the combustion is going to take place at constant pressure, theoretically speaking. Actually, in actual working conditions, this is how the PV diagram will look like. So during the combustion, we can see that there's a change in the pressure rapidly increases because of the combustion that is happening into the piston cylinder arrangement. Okay. Now moving on to the power stroke. So during the power stroke, what happens? The piston moves from TDC to BDC. So volume into the piston cylinder arrangement increases. Okay. And since the volume increases, because of the high pressure that has taken place during the combustion, it is going to go down. That is, the pressure is going to decrease since the volume is going to increase because the piston is going to move from from TDC to BDC. The volume is going to increase, thereby the pressure inside the piston cylinder arrangement is going to be lowered. So thereby we can see that during the power stroke, there is a change in the volume, that is, the volume is going to increase. The piston is going to travel from TDC to BDC. So since the volume is going to increase, the pressure is also going to decrease. And during the exhaust stroke, what happens? Now during the exhaust stroke, the outlet valve is open. The piston is going to travel from BDC to TDC. That means compressing the content that is present inside the piston cylinder arrangement. That is nothing but the volume is going to decrease once again, right? But the pressure will not change because the outlet valve is, or the exhaust valve is open, which is connected to the atmosphere through the silencer. So there will not be much change in the pressure. Only volume change will take place during the exhaust stroke. So during the exhaust stroke, we can see that the arrow mark moving in this direction, that is, the piston is going to move from BDC to TDC, compressing the volume, but there will not be any change in the pressure because the exhaust valve is open, which has been connected to the atmosphere. So there will not be much change in the pressure at all. It will be at, the volume will change at constant pressure, and thereby at the end of the compression stroke, it has reached once again the starting point, that is the point A, right? So this is how the PV diagram is written. Okay. Yes. So here, uh, we can see that uh, we have to write all these four diagrams indicating one stroke for every diagram, how the piston cylinder arrangement, the piston or the engine works for a four-stroke petrol engine. So in the first stroke, okay, the inlet valve is going to be open. The piston moves in the downward direction, that is from TDC to BDC. The crankshaft rotates for half a rotation during the suction stroke, and we can see that the inlet valve is open, exhaust valve is closed. So during this time, the pressure inside this piston cylinder arrangement decreases. So thereby air fuel mixture is being drawn in. So this is what has been indicated in this first diagram, which is the suction stroke. So in the second diagram, that is the second stroke, the compression stroke, inlet valve, exhaust valve, both are closed. The piston moves from BDC to TDC. So the crankshaft was previously at this particular point at the end of suction stroke. Now the crankshaft is going to rotate for another half a rotation, okay, as the piston is going to be moving from BDC to TDC, right? And during this time, the air fuel mixture is being compressed, and at the end of the power stroke, sorry, this compression stroke, the spark is being introduced where combustion takes place. And in the third diagram, which is the power stroke, so at the end of the compression stroke, the crankshaft was here, okay, the crank portion was here. Now during this power stroke, okay, inlet valve is closed, exhaust valve is closed, piston moves from TDC to PDC because of the combustion that has taken place. So because of that force exerted, the piston moves in the downward direction, so thereby the crank is going to rotate by another half a rotation. And the last stroke, which is the exhaust stroke, the piston moves from BDC to TDC, inlet valve is closed, exhaust valve is open, right? So all this gases that was present after the combustion, okay, is going to be pushed out through the exhaust valve. And during this time, since the piston is moving from TDC to BDC, the crank is going to rotate for another half a rotation, right? So this is what happens in a 4-stroke IC engine. So coming to the PV diagram, what we can see here is the theoretical PV diagram. Okay, right? So point A represents the piston at TDC during the starting of suction stroke. We here have onto the y-axis the pressure, onto the x-axis the volume. Okay, now over here the since the during the suction stroke the piston moves from TDC to BDC, volume increases, so it is the volume is going to be changed. There's an increase in volume from this particular value to this particular value, right? And now during the at the end of suction stroke, what happens? The inlet valve and exhaust valve both are closed, okay, so thereby what happens, uh, there is no now it is no more at atmospheric pressure. Now the piston moves from BDC to TDC, that is the piston moves from point B to point C, speaking with respect to the graph, okay, so there's a change in the volume as the piston moves from BDC to TDC, okay, so there is volume that has been decreased, and since the valve is closed, the pressure is also going to increase, so it is going to reach from point B to point C at the end of compression stroke. Now at the end of compression stroke, we know that there is a spark that is going to be introduced, so thereby within a fraction of a second, combustion is going to take place, so there's not much movement of the piston. So at this same place, there is no change in the volume as the piston has not moved, but compression is sorry but combustion is going to take place, so there's a rapid increase into the pressure, so thereby its value changes from C to D, the pressure changes from point C to D. Okay, so now what happens after this combustion has taken place? Because of this combustion, the piston is going to move from TDC to BDC, that means the volume is going to increase once again from point D to point B. So by so much distance the piston is going to move linearly, and since it is going to, the volume has increased, the pressure is also going to drop down. Okay, the pressure is going to drop down. Now at the end of the at the end of the uh, power stroke, what is going to happen? The exhaust valve is going to be open, which is being connected, which is going to have a connection with the uh, getting it connected to the atmosphere. So thereby what is going to happen? There's a rapid decrease in the pressure, but not in the volume, because it's only the opening of the exhaust valve. Okay, so thereby what happens? There's a rapid decrease in the pressure, and the piston is not yet much moved, so thereby it is still at BDC only. Now during the exhaust stroke, what happens? The piston moves once again from BDC to TDC, right? But exhaust valve is open. Okay, so there is no change in the pressure, only there's a change in the volume. So the piston reaches once again the starting point A. So the all the four strokes are completed, right? And the cycle repeats. Yeah. Yes. So this is what happens in a four-stroke petrol engine, right? Okay. So whenever a question is being asked to explain about a four-stroke petrol engine, all these four diagrams has to be written neatly with all the labelings, and don't forget to mention to draw these arrow marks. Okay, whether the piston is moving in which direction, the crankshaft is rotating in which direction, please do mention all these arrow marks, which will give a complete meaning for the drawing. Along with this, always write the PV diagram also, right? This is also a must which carries marks. Okay, so I'll replay this working of all the four strokes of the IC engine for a petrol version. Okay, once again. So please look at this video carefully. So during the suction stroke, yes, the inlet valve is open, piston moves from TDC to BDC, drawing the air fuel mixture into the piston cylinder arrangement. So at the end of compression stroke,